today we are going to talk about gravitational waves. Now, let us first discuss what is gravitational waves. Gravitational waves is the ripple in a fabric of space and time. They are produced when every mass accelerates, changing the distortion in space. And everything with mass and energy can cause gravitational waves. And according to National Geographic, gravitational waves are produced by the most violent phenomena in the cosmos can offer. Things like exploding stars and collisions between ultra-dense neutron stars or merging black holes. So who was the first person that came up with the idea of gravitational waves? In 1916, Albert Einstein suggested that gravitational waves could be a natural outcome of his general theory of relativity, which says that every massive objects distort the fabric of time and space, an effect we perceive as gravity. And accordingly, very massive objects spiraling toward each other should wrinkle space-time and send those distortions across the cosmos like ripples spreading across a pan at the speed of light. Now, why should we know and care about these things? Since LIGO's first detection, we have gained unexpected insight into the cosmos. That's because gravitational waves are a new way of seeing what happens in space. We can now detect events that would otherwise leave little to no observable light. And with this latest detection, astronomers were able to combine gravitational waves of seeing the universe, helping to untangle mysteries about the dense, dead objects known as neutron stars. Now, when did astronomers directly detect gravitational waves? Well, in the 1970s, scientists observing a pair of pulsars orbiting on one another indirectly detected gravitational waves for the first time. Using the giant radio telescope in Arecibo, Puerto Rico, the team had measured the orbits of the two pulsars and determined that the pulsars were moving closer together. For that to happen, the system must have been radiating energy in the form of gravitational waves, an insight that earned Joe Taylor and Russell Hulse the 1993 Nobel Prize in Physics. But it wasn't until 2015 that the LIGO team had directly detected gravitational waves. Using a pair of ultra-sensitive detectors, the discovery ended a century of speculation and confirmed Einstein's original predict. Now, to explain other things, let me present to you my partner, Mr. Sharvan Lubayani, to discuss real-life application of gravitational waves and how it works.
Oops! Hello dear listeners. So basically, gravitational waves are ripples in the fabric of space and time. Imagine that space is a giant sheet of rubber. Things that have mass causes that rubber sheet to bend like a bowling ball in the trampoline. The more the mass, the more that space gets bent and distorted by gravity. For example, the reason why Earth goes around the sun is that the sun is very massive, causing a big distortion space around it. If you just try to move in a straight line around such a big distortion, you will find yourself moving in a circular motion. And that's how orbit works. There is no actual force pulling the planets around. It is just by bending of space. Gravitational waves are produced whenever masses accelerate, changing the distortion of space. Everything with energy can make gravitational waves and can produce by the most violent phenomena on cosmos that produces much energy, and as a result, gravitational waves are produced.